Hi everyone, this is Al from Skald. Today I thought I'd make a short video where I do some programming and you can follow along if you want to. I think it's a good way to kind of get an impression of the game and how the engine looks under the hood. So just tag along. If you enjoy the video, leave a comment and be sure to subscribe. For this video, I think we'll actually dive into something that's a little easy to get into. I think I'm going to do some refactoring and probably also implement some new features relating to vehicles and ships in particular. So just follow along and we'll see how far we get today. I don't really see this as a tutorial at all. And also if you're very familiar with C# and with the Unity programming environment, I don't think you're going to get a lot out of this beyond being able to see under the hood of the Skald engine and get to know me and the way I work a little bit better. So feel free to follow along and leave feedback. That would be very much appreciated, both on the format of the video and also on the technical side of it if you feel like it. And also please ask questions. That's awesome. Okay. So this is Unity, which is the game development software that I use to make Skald. I use Unity, of course, in conjunction with Visual Studio, which is the coding environment that I use to write the code for Skald. Today we're going to look at the vehicle container C# file and try to do some development and some refactoring. There's already some code there. We're going to look over it and I'm going to try and explain the way I think about it and how we can improve it and make it more sustainable for the future. Okay, so looking in the file vehicle container, there is a class called ship container. Now, a ship container is a class that encapsulates the ship class, and it occurred to me when I was looking over it that this was actually pretty bad in terms of thinking ahead, because what happens if I want to make a game that has vehicles beyond just ocean-going ships? Maybe I would want to make vehicles, other forms of vehicles. It could be like a magic carpet from the Ultima games, or even if I use the Skald engine to make something post-apocalyptic, maybe adding vehicles, spaceships, you never know. So this needs to become more generic, and I also need to start fleshing out the ship object itself. As you can see now, this is a tiny little class that's nested inside the big ship container class. So and there's nothing in it right now. The game doesn't use any information from the ship. There is no field for the title of the ship or adding different animations for different ships and so forth. And we're going to try to see if we can do something about that as well. You might also ask, why isn't the ship contained in its own C# file? Why is the ship nested inside the ship container class? And what's the purpose of the ship container class? Well, the ship container does several different things. One of them is that it instantiates ships or vehicles. So if a tile on the map has a ship container and I need to create a ship on that tile on the map, it's up to the ship container to create the ship or another vehicle, as it were. So and it also does some other things as well. All the tiles on the map have ship containers, and if I want to move a ship from one tile to the other, it's up to the ship container on one tile to hand it off to the neighboring or to the target tile's ship container. So it does some of those things so that it doesn't end up being the responsibility of the ship class itself. The ship class is purely there to contain the data and logic that pertains to the ship itself, not to the moving around of the ship, for instance. So the first thing we are going to do is to make a parent class for the different types of vehicles. Today there is just one class called ship, and it inherits from Skald object. Skald object is a generic parent class that I use for most of the in-game objects. We'll probably look at it later, but not now. So what we'll just do is we'll just copy the ship. Let's see, and we'll just use it as a template for the vehicle object. Vehicle, and then we'll have the ship object inherit from vehicle instead. And that should do it. So for those of you who don't know, inheritance is a feature in a lot of high-level programming languages like C#. Object-oriented languages like that tend to be very modular in the sense that you can create a parent class such as this, the vehicle, and then add some features to it, and then create children who are more specialized versions of the parent. So they can, for instance, inherit data from the parent object, and we could make, for instance, a class like, let's say, flying carpet. Flying carpet. So this would be another type of vehicle, and whatever we put into this class would be passed down to both the children, but then the children could be more specialized in their own sense. So it's a pretty neat way of reusing code, and it's very common in languages like C#. But we're not going to add a flying carpet right now. I don't think there is a place for it in the Skald universe, at least not now. Yeah, but we have at least now made the ship a type of vehicle, not just a ship. And that means that we can also go up here. We can start by renaming this to vehicle container. Vehicle container, apply, and then this, we could rename this to refer to the vehicle and not just a ship. And that means that this should probably also be vehicle. I think we will probably get some errors. This should return a vehicle. This variable should be a vehicle. That looks good, and then we have to rename some of these methods. I think this one we can delete. It has no purpose, just left over. Yeah, so here's a method called, or a function called makeShip, and I think we will keep that because this takes the vehicle and it explicitly makes a ship for it. So if we had like the flying carpet and the ship, this function would still be relevant because we could have one called makeShip and another called makeFlyingCarpet to sort of make the specific kind of vehicle that we want. This should be changed to set vehicle. Let's see. This could probably be renamed to get vehicle. And this could be renamed to yeah, so the functions that are in the vehicle container object right now are fairly simple. There is one that makes a ship. If there is no ship, it makes a ship. It makes a ship either way, but you use it to populate the vehicle container. And then there is another, there's a typo here. Let's see. No, there isn't. We use this to take another vehicle container and say take the vehicle take the vehicle from that vehicle container and put it into this vehicle container instead. So it just sets the vehicle container to the other vehicle container's vehicle. And then there's the get vehicle method, which doesn't just return the method. It doesn't just return the vehicle. It also clears the vehicle variable so that there is no vehicle left in the container. It basically pushes the vehicle out of the container, and it's used, for instance, to move the vehicle from one container to the other. And then there is also a Boolean function that just tests if there is a vehicle currently present in this vehicle container. So the use for these three methods in particular is to move vehicles around on the overland map by basically moving it from one tile to the other via the vehicle container. So now we have already refactored it a little bit. Now we could add we've made it a lot easier to expand. And we will save and we'll test it, see if it breaks somehow. I don't think it should. It should be pretty okay. Let's see. Pre-made party. Starting on the overlands. Yeah, it works fine. That's good. That makes me happy. Okay, so returning to our vehicle container, we're now going to add some data and try and see if we can make different types of ships using this container as a constructor. So I think we'll start by adding some variables here. The model path variable, which is, no, we can just leave it uninitialized, which is basically a path to the model that will show on the overland map from the vehicle, and we will add public get method for the model path. So we can get the model path if we need to. We'll just write it out instead of using the shorthand because you never know what we'll want to put in there later. Let's see. And I think the model path of the vehicle should be accessible probably through the vehicle container instead of the vehicle directly. So you have to ask the vehicle container if it has a vehicle, and if so, please return the model path. We'll have to modify the axis, change the axis modifiers later. We'll look into that a little bit later. Let's just see if we can get it to work now. So we have another model here. Call it get vehicle model. If we have a vehicle, we will return let's see, let's not use the get vehicle method. We can just reference the vehicle directly. Get model path, else we will just return an empty string. Not all paths return. Oh yeah, we forgot the return. Return. There we go. So now we should be able to, yeah, and so the idea is that like we were talking about with inheritance earlier, this is the parent class. It has the method of get model path, and we don't have to rewrite the method in the child because the child will inherit this from its parent. So it makes it a lot easier to reuse code. And what would be really cool now is that we can make different classes of ships We can use ship as a parent of all ships, and then we could have a new subtype of ship called Caravel. Is it one or two else? What did I use? One. Caravel. And we could have another type ship called Cog. A Cog is a Scandinavian ship from the late Middle Ages, which was very seaworthy and had a big cargo hold, so it was an excellent trading vessel. Let's see. And now we could make this into more of a factory method, where we could have it take a string as input, which would be a type of ship, and then we could do if type is, now let's see, Caravel. Then we create a Caravel. If not, if the type is Cog, we create a Cog. Or else we could just create any type of ship, perhaps. Yeah, we might do that. And we might also include an override method as well, in case we just want to make a ship. Let's just do it for debugging purposes right now. If we don't want to provide a type, we can just use this instead. Oops. Make ship. So now it's possible to call the make ship method providing a ship type. If the type isn't found, we will instead create a ship not providing a ship type, in which case we will create a generic ship. Yeah, so this looks fine for now. Let's see here. We could also provide sort of a default model path, perhaps. Yeah, so I had to look it up, and it's, of course, this is the model path for the parent object, and this should filter down. And then what we do is that we override it in the children. At least here in the cog, for instance, we don't want to use another model cog, and we could also just add it here in the Caravel as well, in case we change the default. Now let's see. The vehicle class could probably be an abstract class. It doesn't really need to become instantiated anytime. So it could be abstract, meaning that you will only ever create children of the class. This is only for containing data. And we could also make this protected, just to seal it off even further. That shouldn't cause any errors. But we should be able to make ships, because you sometimes just want to make a default ship. And come to think of it, this should actually reside in the ship class as well, because the vehicle can be any kind of vehicle. And since we never want to create the vehicle without creating one of the children, we will never end up in a situation where we don't already have a model path defined for it. So that should do. Now let's just see here. Is this okay? Oh, there is an error here actually. The way it's now, this is a very typical. We forgot an else. So this means that the way it's now, it will either test to see if we are trying to build a caravel, then it will build a caravel. If we're not building a caravel, we will try to see if we're building a cog, and then it will build a cog, but it won't terminate the function. It will continue, and it will make a ship as well, a generic ship nonetheless. And that's not what we want. So we want to do this and this. Now it should work. Now we should have a little factory that builds boats for us. Let's see here. Okay, so here we have the caravel is working excellently. Let's try to make another boat using the command line. Create ship at 812, and we try to make a cog. Yeah, it works. There we have the cog. Very cool. That reminds me, for methods such as this, at least I always take the type and set it to uppercase string, in case you forget to write the type in uppercase. The function shouldn't fail, so it will just always uppercase it all, so it's certain that the casing will match. Makes it case insensitive. Yeah, that's it actually. I think this is it for today. If you like this video, if you want to see more of this, just let me know. It's no problem making them, and it's a nice little diversion for me as well to have someone to talk to while I'm working. So like I said before, leave a comment, like the video if you do, and join us on Discord or check out the devlog for the game. I'll leave everything in the comments below. Okay, bye bye.